So I hear that my memo wasn't entirely helpful and you still have some questions. So let's get after those. What I want to address first, acute myeloid leukemia. That's what you're looking to get some testing done on, to see if you have markers or if you have something that could mean that you would develop the cancer later. So, a couple things about those testings. So we have something called FISH. It stands for fluorescent in situ hybridization. Um, what this test does, I know it's a big word, is it's a test that uses glowing or fluorescent probes to find a specific change in chromosome inside the cancer cell. So it basically shines a big old light on what is going wrong with your certain cell and why these mutations are happening or not happening. So how it works is scientists they just designed this glowing probe um, that sticks to specific markers in your DNA where the mutation is suspected. We can kind of tell based on all of your sequence of your DNA, which ones should be there, which ones shouldn't be there, and where we're seeing extra and where we're not. This test really just, like I said, puts a big old spotlight on it so you know where the problem is and you can target it. Because that's what we're looking for when we're doing genetic testing, is we're looking for targeted therapies that can attack whatever is happening head on, and instead of possibly helping you out with something else or treating some of your symptoms, not treating others, things like that. So basically, targeted therapy is the name of the game. What it can find for us is some missing pieces or extras. So you have a pretty specific sequence when your DNA is produced. When you have extras, it can mess with the whole process. And obviously, if you have missing, it can also mess with the process. So we like to keep it in line and we like to keep it in that perfect formation. So this basically just calls that to our attention so we can see exactly where your body is deficient or is not working correctly. So those are some of the tests that we can do. Now let's talk a little bit more about AML. So it is it's about 20,000 new cases are diagnosed each year. So on the rarer side, but it, it makes up 1% of all cancers. Again, still pretty rare. Um, and it is the most common type of leukemia in adults. I believe generally when the average person thinks of leukemia, they think of children normally getting it, whereas that is not the case for AML. AML is largely affecting our older age ranges. So it is very rare to find someone under 45 who has AML. The average age is about 68 or so is when people are diagnosed with it. And it's extremely rare in younger children. So odds are that you're not going to find this early in life. So genetic testing can kind of give us a little scope into the future to see if there's a possibility that this could happen to you. Because it is, while being very rare, it is also very serious when it happens. Another thing also is that it slightly affects men more than it does women, which is good to know. Race, generally white Americans are more affected than other racial groups. So if you are a white American, doing a genetic test for this would not be a bad idea, especially if you are a male as well. So there's a couple key mutations that are shown to us when we're looking for AML in someone. I'm not going to bore you with those details, but a few things maybe would be nice to know, that like a DNA mutation, one in particular, it helps regulate which genes are turned on and off by adding small chemical tags to DNA. So that's a little thing that we can look at. It also has some mutation effects, and this gene regulates processes when they go wrong. So that's not working, can spell trouble for you. All right, so if there's anything else after this video that you still have questions on or want to reach out about, please don't hesitate. That was more just like a general overview, but we can definitely get into more detail if needed. All right, thank you.